So step 1 was to factor out the GCF. Step 2 was to look for special products. Step 3, if there are 4 or more terms, we're going to look to factor by grouping instead. Sometimes we group in pairs, sometimes we group in threes, sometimes it's 3, 2, 1. We just have to play around and look. There's some tricks to finding each of these. If there are 4 terms and the first 2 terms and the second 2 terms have the same ratio, like for example, if I look at example 5, I can take t cubed and divide by negative t squared. That's the first 2 terms. And the second 2 terms, I can take t and divide by negative 1. When I reduce them, they become the same thing. This becomes negative t over 1 or negative t, and this one is negative t over 1. That's a big clue that you can factor by grouping in pairs. Okay, so we're looking for a common ratio there. It tells us we can factor in pairs. Now, I'll give you advice. When I factor, I tend to not use parentheses because if there's a negative here in the middle, it'll actually change the signs accidentally. So you want to just underline your first step. I know that this one will factor in pairs. And then I ask myself, okay, what can I factor out of the first 2? Oh, look at that, a t squared. That gives me a t minus 1. And then the next one, if nothing factors out, I'm actually going to write a 1. That's t minus 1 because it's easier for me to recognize that this common factor leaves behind an actual 1 there, right? If you write nothing, for some reason, people make that whole term disappear, which it doesn't. There's still a 1 in front of there. So my common factor for this one is t minus 1. And then what's left out when I'm, look, some people, like we did in the other one, let t minus 1 equal a, and they write t squared times a plus 1a. I can factor out the a, I get t squared plus 1 like that. Oh, a was t minus 1. We substitute that back in. You don't have to use substitution. I'm just showing you that that's how it can be done if you struggle with seeing that the whole binomial comes out and why there's only one of them. Now, you double check your answer that's left behind. Oh, look, t squared plus 1. Does that factor further? No, it's a sum of squares. If it was a difference of squares, I could, but because it's a sum of squares, I cannot. If I look at part B, I'm going to do the same thing. I can take like 5x cubed. Now, you're going to eventually do this mentally. You're not going to write it out each time. I'm just showing you. I'm taking the ratio of the first 2 and the ratio of the second 2. Sometimes you may have to rearrange things a little bit, like it's not in the right order or whatever. But in this case, it ends up being x over negative 3 or negative x over 3. This one also becomes negative x over 3. Okay, that means I can group in pairs. I'm going to group the first 2. And here it really matters. If you put parentheses in here like this, you've now changed the sign there. That's not good. So you're better off just underlining and then asking yourself, what can I factor out of the first 2? A 5x squared. That gives me an x minus 3. The second 2, look, the leading coefficient of that pair is negative, and it's in one variable. That's why I'm going to factor out the negative 2, not just the 2. And then we get x minus 3. And I also want to point out here, when I'm factoring out something, there's a plus there. You have to write the plus. You cannot just leave it blank there because that means multiplication. Same here. I have to write the minus there because leaving it blank implies multiplication. So you have to be really careful how you write these things. The common factor for this term and this term is the x minus 3. So I can take that out. So I gave you a little bit of a hint to grouping in pairs. That's a quick way to recognize, oh, grouping in pairs will work here. Now, if I do that for the next one, even if I rearranged a bunch of things, that wouldn't actually work. If I took the ratio of the first 2 and the second 2, not going to work. If I take first and third and second and fourth or anything, any combination of that is not going to work. So that's a clue something else is going on. But that something else is easier to recognize if you realize that there's a bunch of perfect squares disregarding sign. So I'm like ignoring all the signs. If this part here is a perfect square, I'm a perfect square. So am this part here, not with the negative, I get that, but like just the number itself is a perfect square. If that's happening in 3 places, most likely it's a 3-1 grouping. So you will look, so this is a 3-1 grouping. look for perfect square trinomial. I see the perfect square the one that's left behind, this guy, he's like the grouper. He's the one telling us what I should group with. It wants to be grouped with the x and the y because it has an x and a y here. So this is actually a good grouping here, the ones I underlined. That particular grouping is a perfect square trinomial, x minus y squared. Take the square root, sign of the middle. Let's double check. Take the product and double. Yeah, I get the middle, minus 25. Then we're going to go in and rewrite this. Look, some people use substitution. You do not have to do this, but if you need it, do it. If I let x minus y equal, let's say a, I'm picking a variable that's not in the problem. I could rewrite this as a squared minus 25. Oh, that's the difference of squares. I'm super familiar with that. It's going to give me conjugates, a minus 5, a plus 5. Cool. But a was x minus y, so then I got to go in and substitute that back in. X minus y minus 5, x minus y plus 5, and I've factored fully. D is similar. The order just flipped around a little bit. So again, I'm looking, disregarding sign. Oh, I'm a perfect square. Me too. And me too, right? So I'm going to, oh, the guy that's left behind is the grouper. He's telling me I want to group it with A and I want to group it with B. So that's my grouping. So I underline again, especially because there's a negative there. So I'm going to write it as 81 minus, factor out the negative. Be really careful. A lot of people make mistakes on this one because they don't factor out the negative. So they mess up their signs. Oh, look, the guy here inside the parenthesis is a perfect square trinomial. We love that for us. Take the square root of the first, 2a, sign in the middle, square root of the last, squared. Oh, take the product and double just to double check. Yep, it definitely was. So we factored that correctly. Then we're going to let a variable that's not in here, call it x, because I can't use a again because that's in the problem already. So that's going to give me 81 minus a squared. Now, some people are like, oh, now it's a single variable, the leading coefficient is negative, I have to factor out a -1. But the original problem has more than one variable, so you do not have to do that here. So I would just make it 9 minus a, 9 plus a, and then substitute back in. But now you got to be careful because you have 9 minus 2a minus b, like that, and 9 plus 2a minus b. And then, okay, we got to polish. We don't have a parenthesis and a parenthesis. We distribute the negative. That gives me 9 minus 2a plus b and 9 plus 2a minus b. If you multiplied those back together, they would work. So again here, I'm looking for perfect square trinomials. Perfect square trinomial happens here. That grouping here. To me, for this, the biggest clue is sitting right there. If I just factored that piece of it, okay, can I get an x plus y somewhere else so that I can use substitution like we did above? But look, if I just group these together and factored out a -4, that would give me an x plus y. Oh, yeah. And then I have this extra 4 on the end. So the perfect square trinomial is the biggest clue here of how to approach this. Sometimes you have to play around with it. If the one thing doesn't work, try something else. This is what makes this fun. It's like it's little puzzles you have to solve. I'm going to use a temporarily. That gives me a squared minus 4a plus 4. Oh, wait, that's a perfect square trinomial, I think. Take the square root of a, sign of the middle, square root of 4 is 2, squared. Take the product and double to double check. Yeah, it works. Oh, but a was x plus y, so I'm going to substitute that back in. Okay, that factors. So if you multiply, you could try it on a piece of scrap paper. Multiply that out, you should get what we started with in E. Okay, F, 4 terms, messy, 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 messy. I'll tell you, a lot of people, they see the ratio, you have 6 over 3, and then negative 6 over negative 3 is also 2. Most likely, it's a grouping by pairs. So a lot of people group right away. They go, oh, this and this here, right? And then they factor out the common factor for each one. All works, but you missed the GCF. So I told you guys earlier in a previous video that if, let's say you missed and you forgot to do the GCF in the beginning, you can catch it in the end. So let's say we did that. I would prefer that you took out the GCF, but we did it this way. What can I factor out of the first two terms is a 3. I can factor out, it looks like an m squared. I can factor out, an x and a y cubed. And that leaves me with, I'm just left with a y in the first one, plus a 2. I think we got everything there. The second one, because the leading coefficient is negative, I'm just going to take out a negative. I can take out a 3, an m squared, a y, and an x, and that's going to leave me with a y plus 2. Okay, so now we have this common factor of y plus 2 that I can factor out. That's cool. So now I have y plus 2, and then I have 3m squared xy cubed minus 3m squared. I'm probably going to rearrange this as xy just because multiplication is commutative. So you might think you're done, but I can tell that I missed the GCF because these two have a common factor. So you should always mentally check the factors that I have, do they factor further? So then that means, this here, I could factor out a 3, an m squared, an x, and a y. And that leaves me in this factor here, a y squared minus 1. And I still have that y plus 2 here I'm just going to add it on the end here. Oh, wait a minute. This is a difference of squares. Like, you would totally miss that if you didn't take out the GCF. Now, like I said before, I'm A-okay with you just waiting till the end to take the GCF out. It's a way to kind of catch your mistake. So this is why I'm showing you this example. If you took out the GCF at the beginning, I feel like the rest of the problem might be a little bit easier, but you have a way out if you forgot, is what I'm trying to say. So now we have the difference of squares. So that's why I'm showing you this way. Now I want you to try it and take the GCF out first and then factor using factoring in pairs and then factoring fully. You should see that you get the same answer.